So today we're talking about graphing proportional relationships, graphing on a coordinate plane and observing whether the graph is a straight line through the origin, and identifying the unit rate in tables, graphs, equations, and verbal description of the proportional relationships. So when you enter your foldable into your notebook, you should glue down the right-hand side of your page to the edge of your notebook and cut the left-hand side of your page into flaps, right? So that you can fold them over and open and close the windows for each topic. You also might want to write the topic on the front or the cover of the foldable so that it says tables, graphs, diagrams across each tab so you know what you're looking at before you open it. We're going to look at how ratios are explained in all of these different models. So the first one is in tables. We talked about this a little bit in the previous video. But this says the width of my house is 30 feet. How many inches is this? First of all, you always need to label a table. So I'm going to label feet and inches. If my house is 30 feet, I know 1 foot has 12 inches. So 3 feet has 36 inches and 30 feet has 360 inches. Again, I always want to label. I also began with a ratio that I knew, which was 1 foot compared to 12 inches. And then I used that ratio to change into 3 feet. So I took 1/12 and I changed it so that if there were 3 feet, I could figure out how many inches, which is equal to 36. And then I used what I know about zeros, so I changed the 3 to a 30 and the 36 to 360, and I got the correct answer. When I look at the graph, it says the table and graph below show Lacey's pay for a different number of hours. Complete the table using the graph. So I went through my table and I said, okay, time worked per hours is the first data point, so it goes from 1 to 2 to 3 to 4 to 5. And then it says the pay in dollars. That's my second data point. 15, 30, 45, 60, 75. So the ratio of pay to hours is in the opposite order, right? Pay comes first and hours come second. So 15 to 1, 30 to 2, 45 to 3, and so on. When I look at the graph, as long as a graph has a straight line, it is proportional. And that can be a straight line in any direction, right? If it goes kind of on a diagonal, if it goes straight across, if it goes down, those are all straight lines. What I'm discussing is a graph that goes like this is not proportional, right? And how do we know when a graph is proportional? It is a straight line. Our next example has to do with diagrams, and it says which pitcher will have the strongest lemonade flavor, or will they taste the same? So I should have here 2 tables, one for pitcher A and one for pitcher B. Pitcher A shows 2 cups of lemonade mix compared to 3 cups of water. So as I continue, if I had 4 cups of lemonade, I would have 6 cups of water. If I had 6 cups of lemonade, I would have 12 cups of water, right? Pitcher B has 3 cups of lemonade compared to 4 cups of water. So if I increase my ratio, I go from 6 to 8, and then again from 12 to 16. So what I really want to focus on in diagrams is that the picture provides the information needed to collect my data. So I always want to refer to the picture. And then I want to be sure that I'm answering the question correctly, right? So as I go through my comparisons, I want to be sure that I'm really understanding what the ratios are. So the ratio in here is 2 to 3. Again, 4 to 6 represents that. 6 to 12 does not necessarily represent that. So I need to go back and edit a little bit. 6 would be to 9. So, and then in my picture B example, 3 to 4, 6 to 8, 12 to 16 is correct. I want to find a common ratio of lemonade or water, etc. So when I actually have 6 cups of lemonade, in picture A, I have 9 cups of water, and in picture B, I have 8 cups of water. So the more water I have mixed with my lemonade, the weaker the flavor is going to be. So the question says, what's the strongest lemonade flavor? And I'm going to go with picture B. Right? And that's because there's less water per the same amount of lemonade comparably in the jugs, right? So when I move on to equations, circle a ratio that is not equivalent in each group. I want to be able to identify that I can't have 1/2 of an odd number. So immediately I know that the ratio, which is not equivalent, is a 24/51, right? It says now it's my turn. I want to just go through and look at the smallest ratio and think comparably of if these can be similar. So 3/4, 60/80 is the same as 6/8, which is the same as 3/4. So I'm good here. 12/16 is also 3/4. 75/90. I need to make this a little smaller in order to understand, so I'm going to divide by 15, which gives me 7 over, wait, I don't think that's 7. I think that gives me 5 over 6, which is not equal to 3/4. So I know 75/90 is not an equivalent ratio. I can check 42/58. If I simplify that out, though, I'm going to get 24 28ths, which would then, I'm sorry, 21 28ths, which would divided by 7 would be 3/4. So that does work out, right? So I know that the ratio that's not equivalent in the group is 75/90. This is all about equivalent fractions and making sure that when you simplify all those fractions down, they are all equivalent and equal one another. Lastly, if I have a problem in words, I want to be able to take those words and change them into a numerical representation. So equivalent ratios from the chart, it says 1 pint equals 2 cups. So comparing pints to cups, 1 pint equals 2 cups. I have 2 pints of strawberries. A recipe calls for 5 cups of strawberries. Are 2 pints enough? So basically what it's saying is 2 pints equal to 5 cups. So my ratio, in order to get from 1 to 2, I multiply by 2. So if I wanted to go from 2 and figure out how many cups there would be, I'd multiply by 2 and get 4. So 2 pints is the same as 4 cups. Is 4 cups as much as 5 cups? No, right? If I have 4 cups, then I don't have 5 cups. I don't have enough. I'm short 1 cup, which means if I only have 2 pints of strawberries, I do not have enough for my recipe. Don't forget to do your proof problem. It's a graphical problem. It says the graph shows the hours worked and total pay for Paul's part-time job. Use the graph to find equivalent ratios and list them in the table below. It also asks you to predict the pay for 25 hours.